Carboxylic acid containing more number of carbon atoms are odorless. Okay, first I will give you a detailed answer, then I will give you a statement answer. This is the key point. The odor depends on volatile nature. More the volatile character, more will be the odor, more will be the smell. Okay, so if you take small molecules, okay, for example, we are taking ethanoic acid, acetic acid, right? Between ethanoic acid, see, surface interaction is comparatively less, right? Compared to the other molecules. See, we take a bigger molecule here. You can see large surface interaction, right? So more intermolecular force exists here. Okay, if intermolecular force increases, what about the volatile character? See, their volatile nature decreases. The ability to become vapor decreases. So only less amount of vapors reaches our nose, so we feel it as odorless. Bigger the molecule, higher will be the intermolecular forces. Okay, so what happened to their volatile character? See, their volatile character decreases. The ability to become vapor decreases. So lesser vapors reaches our nose, so we feel it is odorless. Here is your statement answer. Carboxylic acid with a higher number of carbon atoms are odorless because they are less volatile due to stronger intermolecular hydrogen bonding and higher molecular weight. Their reduced volatility prevents them from easily evaporating into the air, making their smell less noticeable.